Hello everyone, in this video we're going to talk about the trig values of any angle. But before we begin, let's review the three trig functions associated with the right triangle. The first trig function is sine. Sine is opposite over hypotenuse. So if we take a look at our right triangle and we look at angle theta, which is down here, the side opposite would be side A, and the hypotenuse would be side C. The next trig function is cosine. Cosine is adjacent over hypotenuse. Again, if we look at angle theta, the side adjacent would be B. That is the side that touches that angle that is not the hypotenuse. So adjacent would be B and hypotenuse would be C. And then for tan, we have opposite over adjacent. So if we look at our angle theta, opposite would be A and adjacent would be B. So let's see how these relate to the 6 trig functions that we talked about when we did the unit circle. The 6 trig functions that we have are sine, cosine, tan, cosecant, secant, and cotan. And from the unit circle, the sine was the y value, cosine is the x value, tan is y over x, and cosecant is the reciprocal of sine, which was 1 over y. Secant is a reciprocal of cosine, 1 over x, and cotan is x over y. However, if you have a circle that's not the unit circle, the radius can change. So if you look over here at the drawing that I have, we have an angle, and the side that's over here on the x-axis is called the initial side, and the side over here that forms the angle is the terminal side. And the terminal side is the one that moves to form whatever angle that we have. And on that terminal side we have a point. Now, that point can represent a point on any circle. And if you think about this part right here, could be the radius of that circle, which would also be the hypotenuse if I drew a right triangle from that point, where the height of this triangle would be the y value, and the base of this triangle would be your x value, and the right angle would be right here. So the hypotenuse becomes the radius of whatever circle could be drawn in that spot. With that being said, sine now is going to become y over r instead of 1. Cosine is x over r. Tan is still y over x. Cosecant will now be r over y. Secant would be r over y. And cotan will still be x over y. So let's look at some examples. So we're going to sketch a right triangle to represent tan theta equals 3/4. And they are telling us that theta is in quadrant 1. Then what we're going to do is find the other 5 trig functions for theta. So the first thing I want to do is I want to draw an axis. I want to draw the x and y axis. And so I'm going to come over here and draw hopefully a straight line. The x and y axis. So here's the y axis, here's the x axis, and we're just doing a brief little sketch. And we know that the triangle is going to be in quadrant 1. So what I'm going to do is I'm going to come out from the origin. I'm going to draw the radius or the hypotenuse of that triangle, and I'm going to drop down to the x-axis. That's going to form my right angle. Now remember, tan is opposite over adjacent. Theta is always going to be that angle that's formed right next to the origin here. So we're going to compare always to that angle. So tan is opposite over adjacent. So we're going to go opposite, which is going to be 3, over adjacent, which is 4. And also tan is y over x, so it makes sense that the opposite side would be the y value here, and the adjacent side would be the x value here. So y over x. Now that we've done that, we're going to be able to use this triangle to find all 6 of our trig functions. Now, in order to do that, I need to know the radius or the hypotenuse of this triangle. So what we're going to do is we're going to use Pythagorean theorem. So we have 4 squared plus 3 squared equals the hypotenuse squared, and we're going to call that hypotenuse r for radius. And then what we'll do is square root both sides. So 4 squared is 16, and 3 squared is 9. That equals r squared. Opposite of squaring is square rooting, so I'll square root both sides. And usually when you put a square root, you put a plus or minus. However, the radius or the hypotenuse will always be positive, so we don't have to worry about that. 16 plus 9 is 25. Square root of 25 is 5. So the hypotenuse or the radius is going to be 5. Now we can list all 6 of our trig functions. So we're going to list first sine. And what I like to do is I kind of like to write them out like this. I'll go sine theta, cosine theta, and I know they already gave us tan, but I'm going to list it as well. I like to put them in order like this. And the reciprocal of sine is cosecant, so I'm going to put cosecant over here. The reciprocal of cosine is secant. So secant theta, and reciprocal of tan is cotan theta. And let me make that look a little bit better there. Cotan theta. Now, what we're going to do is find all of these values based off of the triangle that we have over here. So sine is going to be opposite over hypotenuse, or you can say y over r. So looking over here at our triangle, we got y over r, opposite over hypotenuse, which is going to be 3 over 5. Cosine is going to be x over r, or adjacent over hypotenuse, x over r. So that's going to be 4 over 5. Tan is y over x, which we already knew tan because they gave that to us. And now that we've done that, we can find the other 3 because they're just the reciprocals. So since sine is 3 over 5, cosecant is going to be 5 over 3. Since cosine is 4 over 5, secant is going to be 5 over 4. And since tan is 3 over 4, cotan is going to be 4 over 3. And there you have it. There's your 6 trig functions. Let's do another example. Next example. Evaluate the 6 trig functions for cosine theta equals 1/6 and sine theta is less than 0. Now here they give us a little bit different information. So they tell us that sine is less than 0. So if sine is less than 0, that means sine is going to be negative. Also, we know that cosine is 1/6 and 1/6 is positive. So we need to figure out which quadrant this angle is located in, because I'm using that cosine is positive and sine is negative. So if you remember, the first quadrant is plus plus, second quadrant is minus plus, third quadrant is minus minus, and fourth quadrant is plus minus. So cosine is like x, so cosine is positive, sine is negative, and sometimes I'll do like a highlighting thing. Cosine is positive on this side. You can't see my highlighter very well, but cosine is positive over here. Let me try something different. Let's do this. Crayon. Here we go. Cosine is positive over here, and sine is negative. Sine is negative down here, and you see where they're both, that would be in the fourth quadrant. So that means that this angle is located in that fourth quadrant. All right, let me clean this up for just a second. All right, so now let me draw the x and y axis. We know that we're in the fourth quadrant. We're going to start at the origin, draw the radius, the hypotenuse, and then we're going to go towards the x-axis and make that right angle. And there you have it. There's our triangle. Now cosine is 1/6. Theta is going to be this angle right over here. There's theta. So we're going to say cosine 1/6 is x over r. X, this value here, r is going to be here. So we need to find this side over here, which is going to be our y value. So now in this case, we know the hypotenuse. We know the radius. We have to find the y. So I would set this up and say 1 squared plus y squared equals 6 squared. So that 1 squared is 1, so 1 plus y equals 6 squared is 36. And if I subtract 1 from 36, forgot my square there, subtract 1 from 36, I get 35. So y squared equals 35. And I square root both sides, I get y equals plus or minus 35, square root of 35. Now in this case, I have to put the plus or minus because we're looking at y value and we have to decide, is it going to be positive or negative? And we look at our quadrant, since we're in the fourth quadrant, sine is negative, so this side's going to be negative square root of 35. The other thing is, if that square root simplifies, you want to make sure you do that. But 35 is just 7 times 5, and it will not simplify, so we're just going to leave it like it is. Now let's write down our 6 trig functions. Sine theta, cosine theta, tan theta, and then we're going to say cosecant theta, secant theta, and cotan theta. Again, we already know cosine, so I'm going to go fill that in. And since we know cosine, we know secant. Secant's the reciprocal. So the reciprocal of 1 over 6 is going to be 6. So those two we already know. So now let's take it to the triangle over here and let's find sine. Okay, so for sine, and I'm going to change my color so you can see where I point. All right, so for sine, we're looking at theta right here. And sine is going to be y over r. So that's going to give us negative square root of 35 over 6. And there you have it. Okay, let me move some of this stuff out the way. There we go. All right, now let's find, we'll come back to cosecant in just a moment. Let's find tan. So tan of this angle right here is going to be y over x. So negative square root of 35 over 1, which is just going to be negative square root of 35. Now let's do the reciprocals. So cosecant is the reciprocal of sine. So we're just going to take this fraction and we're going to flip it. So we have 6 over square root of 35, and it's negative, and I'm just going to put the negative in front. All right, now there's this rule in math that you can't have a square root in the denominator, so we have to rationalize. So we're going to multiply by square root of 35 over square root of 35. Okay. And when we do that, we get negative 6 times square root of 35 over square root of 35 times square root of 35 is just going to be 35. If you're not sure how to rationalize, there will be another video on that that you can watch at another time. And then down here we have tan is negative square root of 35. Remember that was negative square root of 35 over 1. So when you flip that, you get negative 1 over the square root of 35. And again, we need to rationalize. We're going to multiply by the square root of 35 over the square root of 35. And I get negative square root of 35 over 35. And there you have it. Okay, erase that part. There we go. Okay, so now let's go to another example. All right, so this example, we're going to do the same thing. Tan theta is negative 5/4. We know cosine theta is less than 0. So we're going to find the 6 trig functions for this situation here. So if tan is negative, so think about your quadrants. Okay, tan is negative. Tan is negative where sine and cosine have different signs. So that's going to be in the second quadrant and in the fourth. Cosine less than 0. Cosine is going to be less than 0. Cosine's negative on the left side over here. So the place where both of those things happen is right here in the second quadrant. So we're going to draw our triangle in that second quadrant. So let me get my pen. So draw my x-axis, my y-axis. And so in the second quadrant, I'm going to come from the origin, draw my radius, my hypotenuse, drop to the x-axis, draw my right triangle. And again, theta is going to be this angle over here near the origin. Okay, tan is y over x. Now here's where you have to be careful. Tan is negative. But because we're in the second quadrant, which one is going to be negative, the x or the y? Well, cosine is less than 0, so it's going to be the x. So positive 5 is going to go over here, and negative 4 is going to go down here. Because 5 divided by negative 4 is the same, will be the same thing as negative 5/4. Okay, so now we need to find the hypotenuse or the radius. So we'll do our Pythagorean theorem. Negative 4 squared plus 5 squared equals r squared, which gives us 16 plus 25. That's going to be r squared. And so what's that? 11, 41. So r squared is 41. And then we square root both sides. This time we don't have to put the plus or minus because the radius is always going to be positive. So over here we have square root of 41 for our radius. And 41 is prime, it's not going to simplify. All right, so let's write our 6 trig functions. Sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotangent theta. Okay, sine is y over r, so that's going to be 5 over the square root of 41. Again, we can't have a square root in the denominator, so we have to multiply by the square root of 41 over the square root of 41 and rationalize, and we get 5 square root of 41 over 41. Cosine is adjacent over hypotenuse, or x over r, so that's negative 4 over the square root of 41. Again, we're over here, we are looking at our triangle. This is x over our r, okay? So that's where this comes from. And now let's rationalize. So times square root of 41 over square root of 41, which gives me negative 4 square root of 41 over 41. And then tan is going to be, let me move this out the way, tan is y over x. So we have y is 5 and x is negative 4. So we're going to have 5 over negative 4, which is negative 5/4, which was actually our given information as well. So cotangent is going to be the reciprocal of that, which is going to be negative 4/5. Now when I do cosecant and secant over here, you notice how I had to rationalize sine? So I'm going to go back to the original before I rationalize, and I'm going to flip this fraction. So when I flip it, I get square root of 41 over 5. That'll keep us from having to rationalize again. And then secant is going to be negative square root of 41 over 4. And you can think of it as taking the reciprocal of cosine, or you can come over here and know secant is r over x and r over x. Okay? Let's do one more example. And this time we're not given any of the trig functions, but we're just given a point. So we're going to evaluate the 6 trig functions for negative 3, 4. So negative 3, 4 is a point that is on some circle that we need to figure out what the radius is. So let's start by drawing our axis. So what quadrant would this be in? We have negative 3, 4. And if you said second quadrant, you're correct. We're going to come to the second quadrant. Draw my radius. Drop down to the x-axis. Again, we're not doing this to scale. We're just drawing it. So our cosine is going to be negative 3. Meaning my x, I meant to say. X is going to be negative 3, and the y is going to be 4. And now we need to find the hypotenuse. You can do Pythagorean theorem, but this one, if you know your Pythagorean triplets, if it's a right triangle and one leg is 3 and one leg is 4, the hypotenuse is going to be 5. Think about it. You have 16, 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, square root of that's going to be 5. All right, let's get our 6 trig functions. So we have sine theta, cosine theta, tan theta, and then the other 3, cosecant theta, secant theta, and cotan theta. I tell my students if they write it this way, it really organizes it very well. All right, so sine is y over r, y over r, so that'd be 4 over 5. Cosine is x over r, so that'd be negative 3 over 5. Tan is going to be y over x, so 4 over negative 3, which we're going to say that is negative 4/3. And now we just take the reciprocals. So cosecant, reciprocal of sine, which is going to be 5 over 4. Secant, reciprocal of cosine, which will be negative 5 over 3. And cotan, the reciprocal of tan, which is going to be negative 3 over 4. And there you have it, trig values of any angle.